In this video, we're going to look at two different methods of approaching a complex equation question. So we're given z plus 1 times 2 minus I is equal to 3 minus 4i. Now z is a complex number in this, so z is x plus yi, or at least we'll let it equal that. So z is not just a number, it's a complex number. So I'm replacing z with x plus yi in our original equation. Now I might like to expand the left hand side of this. So we have a trinomial by a binomial. I might use the array to do this. Whatever way you organize it, there are going to be 6 different multiplications. 2 by x, 2 by yi, 2 by 1, negative 1 by x, negative 1 by yi. This gives negative yi squared, and a negative I by 1. And remember, I squared is equal to negative 1. So negative y times negative 1 becomes positive y. Our real parts are 2x, our y, and our 2. And the real parts on the left-hand side must be equal to real parts on the right-hand side. So those must all equal to 3. So I'm going to write an equation that 2x plus y plus 2 is equal to 3. If we take 2 from both sides of this equation, we get 2x plus y is equal to 1. So that will be our first equation. Also, the imaginary parts equal the imaginary parts. And we don't have to write the i's in this. On the left hand side we have negative x plus 2y, negative 1, and that must be equal to negative 4. Adding 1 to both sides of the equation gives us that negative x plus 2y is equal to negative 3. Now we're going to solve these simultaneous equations to get answers for x and y. I'll call the equations a and b. If we double equation b and add it to equation a, our x's would be eliminated. So I'll do that. So on top we have a, that's 2x plus y is equal to 1. I'm going to add 2 times b, that'll be negative 2x plus 4y is equal to negative 6. And when we do this, we get 5y is equal to negative 5. Therefore, y must be equal to negative 1, dividing across by 5. If we substitute this value into equation a, for example, we could work out what x is. So we know that 2x plus y, which is plus negative 1, is equal to 1. So adding 1 to both sides, 2x is 2. Therefore, x must be equal to 1. So we solved for x and y. The question is asking us to say what z is equal to. So z is x plus iy. So that becomes 1 minus 1i. And that's our solution for z. So that's one approach to this problem. You could also approach this problem by using division. And this is we're going to look at a second approach to this now. So this time what I'm going to do by using division is I'm going to divide both sides of the equation with 2 minus I. So this is the equation that was given to us. If I divide both sides by 2 minus I, we'll get z plus 1 on one side of the equation. So 2 minus I divided by 2 minus I is just 1. So this gives us that z plus 1 is equal to this complex fraction, or complex division if you wish. So to work this out, we multiply above and below by the conjugate of the denominator. The denominator is 2 minus I, the conjugate of 2 minus I is 2 plus I. So multiply above and below by 2 plus I. So when we multiply out the top, we have 3 2's, 3 by I, negative 4i by 2, negative 4i by I. Now remember, I squared is negative 1, so negative 4 by negative 1 becomes plus 4. Underneath the line, we have the difference of 2 squares. We always get this situation, so that becomes 2 squared minus I to be squared. On top of the line, the real parts are 6 and 4, which is 10. The imaginary parts are 3i minus 8i, which is minus 5i. Our denominator is 2 squared, which is 4, minus I squared, which is negative 1. So 4 minus negative 1 becomes 5. So when we divide 10 by 5, we get 2. And negative 5i divided by 5 is just I. We want to know what z is though, not what z plus 1 is. So if I take 1 from both sides, we end up that z is equal to 1 minus I, or 1 minus 1I.